DNP3 Basics, Lesson 9, Application Layer, Output Point, Object Structure. There are only two types of objects used to issue controls at an outstation: binary and analog outputs. A word about binary outputs, which has been said before, but it's worth repeating. The DNP3 documentation defines two objects that could be thought to be used for binary outputs. One of these, object group 12, is called a control relay output block, or CROB. This is the object that is used to issue binary controls. The other, object group 10, is called binary output. The name may confuse you. Within subset levels 1, 2, and 3, and even 4, this object is not used to issue binary output commands. It is used to return the status of binary output points. That is, it is an input object. When DNP3 was first designed in the 1990s, both object groups 10 and 12 could have been used to issue controls. The structure of object group 10 was determined to lack security and flexibility, so its use for issuing outputs was deprecated. It is used only as an input point. All controls are issued with a function code of select, operate, direct operate, or direct operate no ACK, a qualifier of hex 17 or 28 specifying a count of points to control, where each point has a prefix indicating the point index, a range that defines the number of points to control, and the command structure to be discussed in this lesson. While each message can request control of more than one point, an outstation is only required to accept a message for one point. It is allowed to accept more. The maximum number of controls in a message is limited to what can fit in one data link frame, since a master is not allowed to send multi-frame messages. This maximum is somewhere around 20 points for binary outputs and a few more for analog outputs. Here we see an example of a CROB command from our test tool. The area of the message that defines the command starts with application select function code 3. The next two octets, hex C and 1, or decimal 12 and 1, are the object group and variation for a control relay output block. The next two octets, hex 17 and 1, specify this will be a command for 1 point. The next octet, which is also 1, says the command is for point index 1. And the next set of octets from hex 1 through the end of a bunch of zeros is the actual CROB command. It's 11 octets, and we will explain that in detail later. There are three ways to issue a CROB or analog output control. An outstation must be capable of supporting all three methods, but one or two of them could be disabled for a particular installation depending on security concerns of the utility. The first method is select before operate. With this method, the master sends a message to the outstation with the select application function code. The outstation determines if the control can be processed. If so, it echoes the select command with status code 0. The status code is the final octet in the output object. If it cannot process the command, it echoes the request with a non-zero status code, indicating why the request was rejected. If the master sees a response with status code 0, it sends a similar message, changing only one octet, the application function code, to operate. Again, the outstation determines if the control can be processed. If so, it controls the point and echoes the command with status code 0. If not, it echoes the request with a non-zero status code. The second way to issue controls is with direct operate. The master sends a message to the outstation with the direct operate application function code and the output object to control. The outstation determines if the control can be processed immediately. If so, it controls the point and echoes the command exactly with status code 0. If not, it echoes the request with a non-zero status code. The third way is similar. It is direct operate no ACK. In this way, the master sends a message to the outstation with the direct operate no ACK application function code and the output object to control. The outstation determines if the control can be processed immediately. If so, it controls the point. Whether successful or not, it does not send a response to the master. Something that may concern you is that some outstations may accept a broadcast request with the direct operate no ACK function code. For example, a master may be able to send a single message to control point index 1 at all outstations. It used to be a requirement that outstations support this capability. It is not so certain anymore whether this is still a requirement. Now, as we move on to the actual object structure, I'm going to start by explaining the structure of an analog output command first, because it is a lot simpler than CROBs. There are two types of analog outputs, 16 and 32-bit. There are really more types, but those other types are not part of the subsets and therefore not discussed. The object structure is very simple. The value is sent, least significant octet first, followed by a 1-octet status code. In messages from the master, the status octet is always 0. In messages from the outstation, it reports the status of the operation. 0 indicates that all went okay. Non-zero values are errors. It is not that important for this class why a control failed, only that it did. However, for those that are interested, a complete list of status code can be found in IEEE 1815 Table 11-7. Here we have an example of an analog output command used to control two analog outputs. It starts off with the application header, which is C2 being the application control octet and function code 3 for select. Then a 2-octet object header, which specifies analog output object 41, and variation 2, which specifies 16-bit values. Then qualifier 17, specifying a range, and the range value of 2, saying we are going to control 2 points. The first point starts off with a prefix of the index, which is point index 5. The next 2 octets, 6400, is the value 100, and the final octet is the status byte, which has to be 0 in request. The second point starts off with a 6 for index 6, also a value of 100, and also a status byte of 0. Now CROBs. Before we get into the structure of a CROB, we need to discuss DNP3 binary output types. A binary output, a relay, point, can be latching or momentary. A latching relay can be controlled on or off. It will stay in that state until controlled to a different state. A momentary relay, on the other hand, when controlled, energizes, closes, a relay for a certain amount of time, and then the outstation automatically de-energizes the relay. DNP3 allows momentary relays to be addressed in two ways. The first way is paired. Two relays are addressable using the same DNP3 object index. DNP3 calls one the trip relay and the other the close relay. These are names only. They may, but do not have to, be associated with actual trip and close operations. Each DNP3 CROB command specifies which of the two outputs should be controlled. The second type of momentary relays are unpaired. In this case, only one physical relay exists per DNP3 object index. DNP3 calls this a momentary relay. The next screen presents the definition of a CROB structure from IEEE 1815. If you get into the details, it can be rather complicated. But, as is the general approach in these lessons, I am going to simplify this to discuss only those parts that are supported by the subset levels. Here is the 11-octet structure used for control relay outputs. The first octet is a control code, and you'll see it has many subfields. But since we're only considering subset admissible commands, we'll ignore the individual fields and consider the octet as a whole. You have to be concerned with 5 values. Value 1 is used to issue a momentary control of the type I just described as unpaired. 3 issues a latch on control. 4 issues a latch off control. A hex 41 issues a close control, as in the paired type I explained, and a hex 81 issues a trip control. The count for the subset is always 1. The on time is used for momentary, trip, and close commands, and ignored for latch on and latch off. It specifies a time in milliseconds that the relay should remain energized before automatically de-energizing. Some outstations listen to the message value and use it. Others ignore it and use hard-coded values they know is right. If this is important, you should check with the device manufacturer. The off time for subsets 1, 2, and 3 is always 0. The status code, as explained, is 0 in the request. It is 0 in a response when the control works, and non-zero when the control fails. Here is an example of a CROB command. The application area starts with an application control octet of C7 and a function code of 3 for select. 0C is the CROB object group 12 and variation 1. Hex 17 is the qualifier stating a count of points followed by 1 for 1 point. The following octet is also 1, but this indicates the point index. The 11 octet CROB object follows. The first one specifies a momentary unpaired control. The next field is the count, which is always 1 for subset conformant communication. The next 4 octets, starting with hex 64, specifies the on time of 100 milliseconds. And the final 5 octets are always 0 in a request. They are typically also 0 in responses, since the fifth of these is the status code, which is 0 to indicate success. Okay, that ends another lesson. What did we learn here? Controls are always issued with qualifier hex 17 or 28. These specify a count of points to control and insert a point index before each control. Controls can be issued using select before operate, direct operate, or direct operate no ACK. Some installations may disable 1 or 2 of these options for policy reasons. Some outstations may accept a request to control more than 1 point in a single message. They are not required to do so, but may. CROB commands can be latching, on-off, or momentary, including options for trip and close. Paired or unpaired models implemented in the outstation dictate momentary relay addressing. And there are a lot of features in the CROB output structure that are not required to be supported by subset conformant devices.